welcome back to HBL Seminars. Hope everyone had a great reading week, some time to travel, enjoy, and take some time out of the lab. The weather wasn't great for that, but it's getting back to it. So thank you for joining us today. And today it is my pleasure to introduce our speaker, Dr. Aaron Fox. Dr. Fox is a senior lecturer in the Center for Sport Research at Deakin University in Australia. He completed his PhD at Deakin University in 2016, where his research focused on lower limb biomechanics and their relationship to knee injury risk in female athletes. Prior to that, he completed a Bachelor of Exercise and Sports Science with an honors, with a thesis centered on performance analysis in elite level netball players. Dr. Fox's work sits at an intersection of biomechanics, injury risk, and athlete health, with a particular emphasis on female athletes. And so today he will be presenting his talk titled Anterior Cruciate Ligament Ruptures and Concussion in Women's Australian Football, a Perfect Storm of Injuries. But before I hand it over to him, just a quick fun fact about Aaron. He considers himself a solid chess player, so any chess players out there, you should challenge him while he's here. And while he is visiting Canada, he's hoping to pick up a uniquely Canadian hobby. And so if you have recommendations, use the question period to throw some out. But please join me in welcoming Dr. Aaron Fox for his talk.
Thanks, Ashton. Can everyone hear me okay? Just at the back? Cool. So yeah, thanks for the introduction. So yeah, my name is Aaron. I'm here for a few weeks from Melbourne, Australia, and more specifically Deakin University. This is our relatively new sports science building. On the slide here, I hear you guys are able to see that you guys are getting a new sports science building. I haven't seen the plans, but ours is very pointy. So, you know, you might match it, you may not. But before I sort of get into the topic that presents on today, I wanted to give a bit of a background as to kind of what we do in our research group, where I'm from, and the reason I'm actually here in Calgary, because it's quite different to what my talk is on today. So as Ashton mentioned, I'm from Australia, the southeastern part in Victoria, and I arrived a week and a half or so ago, taking this roughly 14,000 kilometer journey. Came here with my family and 3 kids, so that 16-hour plane ride was a bit of an experience, but also something new that we haven't experienced before. I'm actually from this town in the sort of on the coast of Victoria in Australia called Ocean Grove, and this is a nice, pretty serene picture of where I'm from. I would love to say that my house is in this picture and really close to the beach, but it's a little bit further off to the back left there, but still within, you know, a good sort of 10-minute drive to the beach. And, you know, coming here from summer, 2 weeks ago, I was in this sort of scenario of 35, 40 degrees and literally going to the beach and hanging out there, trying to surf, a couple of days before I came to Calgary. And what greeted me was obviously something very different. Everyone keeps telling me I brought the cold weather with me. I don't think I can be held responsible for that, but looking at minus 20 degrees like on my weather app is something that I have never experienced before. I found it amusing this morning that I left at home and it was like minus 1 degree and I was like, it's warm. It hasn't taken me long to adjust. You know, I didn't need to wear my beanie or gloves or anything. So it's something very new for me, but I am really enjoying it. So this is our 2 sort of sports science buildings on our different campuses at Deakin. I'm from the one down in the bottom left. That's our regional campus in Geelong. And we have a more sort of metro city-based campus in a suburb near Melbourne. And this is our new sports science building. This is our biomechanics lab in this space. It's really great for research. We have a huge amount of space in there. There's a gate lab in the back corner. We have ample room to be doing sort of sports related tasks in the motion capture area. And so, you know, in the past few years, we've really tried to grow the research we're doing in the biomechanics space within our group due to having this sort of lab access. And for sure, I'm open to discussions about collaborative opportunities in this space while I'm here. As far as the people I work with, they'll sort of scroll along on the screen here, but more broadly, our group is really focused on, I guess, any sports performance or injury problem that has biomechanical underpinnings to it. We tend to focus on the lower limb and the knee with our research, but we have, I guess, a vast array of projects going on that kind of fit into this scope. Looking at running injuries, the knee injuries I'm going to talk about today. We have a project ongoing at the moment that's looking at the biomechanics of women returning to running postpartum, as well as various other projects in different sports and in different injury contexts. And we first like to understand the biomechanical mechanisms that kind of underpin these problems, and then move forward into sort of the more clinical space of designing biomechanically focused interventions to reduce injury risk or mitigate pain, or improve rehabilitation. And so that's kind of the scope we work within, and I'm just going to present one small part of that sort of picture today. As far as why I'm actually here in Calgary, it is a bit of a unique research area that we're starting to explore recently, and that is ballet. And in particular, ballet in point shoes and in this point position. It is a uniquely, I would almost say, ridiculous task that ballet dancers are asked to do with respect to their foot and ankle, the positions they're required to get to, and the footwear they're required to do this in. And so we've started looking into this from a biomechanical and footwear perspective. And while I'm here in Calgary, you can see up on the screen here on the right is some of the data we've collected so far in Corinne Roach's dual fluoroscopy lab, where we are trying to get a really good understanding of the motion of the foot and ankle and the stress those bones experience during these positions where they're dancing on the tips of their toes in those point shoes. And as we kind of progress this research into the future, we're really looking to see whether we can develop more advanced footwear for dancers to protect against these injuries that they commonly sustain when dancing on point. So again, if anyone is kind of interested in this space, definitely open for conversations in that area. So now I want to move on to the actual topic of today's presentation, which is Australian rules football, and in particular women's Australian rules football and the injuries that occur in this sport. So I firstly kind of wanted to see a show of hands of anyone who's actually seen Australian football before in the room. Okay, cool. That is more than I expected, to be honest. Does anyone have a favourite Australian football team? No, good. I would have just yelled out like the Kangaroos because that seems like a good Australian name for a team. This one actually happens to be one of the teams playing in this video. So this is from last season's grand final of the Women's Australian Football League, and Kangaroos playing the Lions. And I really don't think I have time in this presentation today to try and explain the rules and intricacies of Australian rules football, because it is a unique sport and a little bit ridiculous in some ways, but it is an open field-based sport where there's kicking and handballing, and players try and score through the goalpost at the end of the field. Now this player is about to kick a goal through the middle of the post. Does anyone know how many points you get for doing that? 5? Yeah, that seems right. It's actually 6 for reasons unknown. I literally have no idea why it's 6. And you get 1 if you go between the other posts. And if you hit the big post, you also get 1 for, again, reasons unknown. So let me just go back to playing that again. Sorry, or maybe I can't. So just to see a little bit of kind of what it's like. Like I said, it's an open field sport. Players are changing direction a lot because of the 360-degree nature. There are long kicks. There can be this sort of play where the ball moves quickly around the ground. Players are allowed to tackle one another, so there is a contact element to this sport. But yeah, the aim in like most sports is to kick goals and score more than your opposition. And like I said, this was from the grand final last year in the women's competition. Fun fact, I don't think this Kangaroos team has lost in like 3 years, so they're pretty good. So what I was just showing you there, a game of Australian rules football at the elite level with women playing. If I had been here 10 to 15 years ago, I would not have been able to show you a video like that. Go back to 2010. Girls and women playing Australian football was a very niche thing. There were 205 teams around the country, and if you think about 15 to 20 players per team. That's about sort of 4,000 players in the country. What happened in 2017 was this elite women's competition, the AFLW, was introduced, and it's really promoted women and girls playing Australian rules football. A few years later, there was a massive growth in the women's teams in the country, and now the most recent data, we've got about 30% of 625,000 participants in Australia are female. So that's up around the 200,000 mark, which is a dramatic shift from 15 to 20 years ago, obviously. Now, this has been, on the whole, looked at as a really positive thing because it's promoting physical activity and sport participation in young girls as well as women, another avenue for them to play sport. But it did come with some sort of negative consequences, particularly at the elite level. So when we look at ACL injuries in female athletes, there is almost an expectation that they will be at an elevated risk compared to male athletes. When we look at soccer and basketball, there is typically a 1.5 to 2 times greater risk for female athletes. And so this was somewhat expected to happen with the introduction of the AFLW, but it was a little bit of a disaster to begin with, where we were seeing rates as high as 7 to 8 times higher in the AFLW compared to the elite men's competition. And so this has kind of continued. It hasn't really yet come back down to the rates you see in other sport. And so research into ACL injuries in women's Australian football continues to be a priority, not just at the elite level, but for those younger girls that are kind of coming through and playing this sport now as well. Today, I'm going to focus on our research in that sort of more elite Australian rules football female player. And so when we saw these high injury rates early on in the AFLW, the first thing we actually wanted to understand was how these injuries were occurring, because it's typically the first step in developing injury prevention practices to understand the mechanisms so you can target these with appropriate injury prevention programs. And so what we're looking at here is an example of what we saw as the most common injury scenario in the AFLW in the first few years of the competition. And so this player from the Adelaide Crows in the red jersey here was directly defending their opposition player from the other team, where this opposition player was performing an attacking maneuver in changing direction, and the player who sustained an injury was performing a reactive change of direction in response to that. And in doing so, in trying to react and change direction, we often saw when ACL injuries were occurring, this typical valgus collapse on the limb that they were changing direction with, and the injury occurring. And so this was about a third of the injury scenarios we saw in the early years of the AFLW. And so it signified to us that this reactive sidestepping task was something that we needed to explore further. So when you look at the reactive sidestepping literature, biomechanical literature, there's actually been a number of studies that have compared anticipated sidestepping to unanticipated sidestepping, and found that in that unanticipated scenario, it's a more dangerous task, the knee loads go up, and it poses a greater risk of ACL injury. So we essentially replicated this study design in a group of AFLW players, so those female players, and surprisingly, we found the opposite. Our data showed that in the unanticipated condition, knee loading, that being the sort of hazardous knee joint movements, as well as the ground reaction forces actually decreased during unanticipated sidestepping. So we sort of needed to explore this in a bit more detail to understand why that happened. And in these studies, we typically control for approach speed, with timing gates as a player is running up and performing a sidestepping task. And we did this sort of up until a point of about 2 meters before the players perform the sidestep, because that's typically where you give the trigger to perform the unanticipated sidestep. And players were running at a similar speed during both conditions, but when we sort of probed this further, kind of at the point that the players were doing the sidestep, we found that in the unanticipated condition, the players were going slower, And so approaching that side step with a slower speed, decelerating more in those last couple of steps before they perform the side step. And so we sort of term this as the players taking a cautious approach in this unanticipated scenario where they're slowing down to react to the stimulus and perform the side step in, I guess, a safe and appropriate manner. There's a problem with this though. When you take a player out to a match specific scenario, they really don't have the capacity to do this, where they're chasing down an opposition player, having to react really quickly. And so we sort of hypothesize that players who want to take this cautious approach in a lab scenario, when they can't do it in the real world in a match scenario, they're going to be placing themselves at a potential sort of greater risk of injury because they can't manage that more hazardous scenario. So to shift gear a little bit here, ACL injuries, a huge problem in the AFLW. Probably the other massive problem in the AFLW and a lot of sports are head impacts and concussion. And again, this was a real concern in the early years of the AFLW competition. When we look at injuries that result in missed matches, concussion has the highest incidence of all injuries in the AFLW. And if you look at the injury report data, every single team in every single year of this competition has had a player sustain a concussion. Like no team is really safe from this occurring. So what we have is this women's Australian rules football competition that is really promoting women and girls' participation in the sport, but has this other side to it where there are these sort of really severe and potentially dangerous injuries like concussion that has long-term impacts on brain health, as well as ACL injuries that have an impact on long-term knee health. And so these are at different ends of the body, being the head and the lower limb. But if you probe the literature in this space a little bit further, there's actually some good evidence that concussion has a potential link to lower limb injury and ACL injury. And I think this makes sense because concussion is an injury that affects the brain, and the brain controls movement and things like balance. And so there is, I think, a fair mechanistic link for someone having a concussion and that impacting their risk of lower limb injury. And there is some epidemiological literature that shows those with a previous concussion are at greater risk of ACL injury. Now, this hasn't been looked at in the Australian rules football space. I think this paper on the slide is in soccer. But given the new competition here, and we're seeing lots of concussions and ACL injury, we really wanted to probe this idea to potentially understand the mechanistic link between these two injuries and look at sort of neurocognition or cognitive function and how that is impacted by concussion and the relationship between that to sidestepping biomechanics to try and understand what aspects of cognitive function that can be impacted by concussion might influence someone's risk of ACL injury. So something to, I guess, understand firstly before I sort of talk about the research that we did is how the AFLW actually tests for cognitive function in players. They do these baseline tests at the beginning of the season and then look at their data again when a player has a concussion. And I've sort of just got one example on the screen here, but they do this test where they show players cards and ask them whether they've seen them before. It's kind of like a short-term memory test that has been shown to be affected by concussion. And this is just one example, but there are other sort of simplistic tests that they use to examine players' cognitive or brain function that while I think it's fair that they test cognitive domains that are affected by concussion, it isn't necessarily sport specific. You guys can keep looking and trying this if you like. I'm actually not sure whether there's any repeat cards in there. So while we think this is fair, we wanted in our research to have a more sport specific or sport themed way of looking at cognitive function in scenarios that we felt players were getting presented in games and was putting them at risk of ACL injury. So Tess Rowley is a PhD student who's nearing completion in our group at the moment. And as part of the early work in her PhD, she put together this test. It's a video-based test where players change direction on the screen in front of the person being tested. and they had to predict which direction that player was going to sidestep in and react to that by pressing a key. And so we developed this test and sort of took cognitive performance from it as how quickly and early they could react to the person changing direction, combined with how accurately they predicted them going. So the next step from this research was to look at how well that sport themed test, or how well those generic cognitive tests potentially related to a more sport themed test, because we wanted to know if those tests that we're looking at in AFLW players had a relationship to more sport specific cognitive function. And perhaps unsurprisingly, we found some weak correlations between most of the generic cognitive tests that they do to this sport themed reaction test. So some other examples of those generic cognitive tests were like a simple reaction time test, as well as other kind of learning based tests with that card kind of structure. So like, is this the same card you saw 1 card ago, 2 cards ago? And so, yeah, I don't think it was surprising that we found very little correlations between these. We did find a moderate correlation between a 4-choice reaction time test to our sport theme test, which again, I don't think is too surprising because it's starting to increase the number of cues or stimuli that a player needs to filter through before they produce a response, which we think is sort of similar to what someone's doing in that sport-specific scenario, looking at the player's body, the player's head position, their lower limb. And so as these generic cognitive tests get more, I guess, complex in nature, in these reactive type tests, we think they have a better relationship to sport-specific tests. So then the next thing we did with both these generic cognitive tests and our biomechanical sort of sidestepping scenario is try to understand what aspects of cognitive function might be related to someone's sidestepping biomechanics. And our theory behind this was that a player who has better reaction time or can better react to complex stimuli, better cognitive function, should be able to perform these sidestepping tasks faster and in a safer manner due to that information processing capacity. And so what we did was set up a lab testing scenario where we had a video projection similar to what's on the screen and what we had in that video test, where the player needed to respond in a particular way to an opposition player performing a task. If their opponent turned around and ran backwards there to continue on with a straight run, if they kicked the ball over their head, they had to do a 180-degree change of direction to follow that. And then the last one, which is where we took our biomechanical data from, was a 45-degree change of direction when that player sidestepped themselves. And so we were expecting to see some sort of relationship between how a player performed on these cognitive tests to how they performed biomechanically in this reactive scenario. The answer was a big thumbs down. Like, we literally saw no relationship between cognitive function or cognitive test performance to their sidestepping, which was a little surprising to us because we had this theory. There is this proposed kind of link between concussion to injury. So we're expecting that those with poor cognitive test results wouldn't do so well in this task. That was not the case. And so the last piece of research I sort of want to talk through before getting to explaining some of this was we took a similar lab setup where we had that reactive sidestepping task, and we wanted to look at the sidestepping biomechanics between players with no history of concussion compared to those who have an acute concussion but have been cleared to return to agility-based training. So this typically happens within a couple of weeks. I think our average testing time post-concussion was somewhere around 30 or so days. Again, we have this expectation that given the link in the literature between concussion and prospective low limb injury risk, that we would see this sort of difference in, I guess, the knee loading during the sidestepping from a safety perspective, but also from a performance standpoint, that those with a history of concussion or recent concussion potentially have some deficits in cognitive processing, and will therefore react slower and perform the task slower. Again, some unexpected results as part of this study that we actually saw no difference between our two groups in the knee loading or the performance-related biomechanical metrics, so things like ground contact time, the speed at which they perform the cut between our acutely concussed and non-concussed AFLW players. So after completing these few studies, we kind of got to the point of being a little bit confused in understanding our results and our ability to kind of hypothesize what would happen in our research. And so there are kind of two explanations in my mind for this. The first is that our theories were wrong. There isn't actually a relationship between sort of neurocognition and these sidestepping biomechanics, particularly in AFLW players. And that isn't what is necessarily driving a potential increased risk of ACL injury in those who have concussion. I don't really like that explanation, and I don't necessarily think it's right because there were a couple of things in our data that kind of surprised us and potentially explain some other reasons for why we saw these results. So I want to go back to that first study I talked about with the anticipated versus unanticipated sidestepping biomechanics. The design of this study was pretty typical, where we used these timing gate system and these light cues to direct players to perform a sidestep or that straight run or a different sort of stop jump task. And what we saw in this study was this typical early knee abduction moment peak, which is associated with ACL injury risk and is quite typical for these unanticipated sidestepping tasks. And so this setup was kind of generating the expected results from a injury risk perspective, that there was this early hazardous loading of the knee joint. When we progressed to using our video cue, and the reason we did this was to try and make our testing more sport specific and I guess more realistic, we actually noticed that in a lot of participants, this knee abduction peak wasn't there. It was there in some, but for most, they were able to orient their body in a way that they didn't have this hazardous knee joint loading. And I guess while we wanted to make this testing more sport specific and realistic, we think we may have inadvertently made it a little bit too easy or a little bit too simple with respect to the stimuli that we were giving players to react to, and they could therefore do it in a safe manner. What this potentially relates to is this dual process model of motor performance, where it's an inverted U model, cognitive load going along the x-axis and motor performance going along the y-axis, where some research has shown that a moderate cognitive load or a not too difficult or not too easy cognitive load results in optimal motor performance. And we somewhat think that this is where we positioned our biomechanical lab testing and that it somewhat allowed our participants to perform this task in a really safe manner. And that's maybe why we didn't see those relationships between cognitive function to sidestepping biomechanics or a potential difference between those concussed and non-concussed players. What is probably more realistic in happening in a match scenario, as well as scenarios where ACL injuries are happening, is that there is this much higher cognitive load, and according to this model, that is going to be detrimental to motor performance, and that's potentially where you might see more high-risk biomechanics or more differences between high-risk versus low-risk groups occurring. So I want to go back to this injury scenario that I showed you at the start of the presentation and sort of play it back, because visually it kind of looks like what we did in our testing scenario, where there is a single player and they are reacting to them going in a particular direction and performing a sidestep. But that's kind of a superficial picture of what's happening here. This match was actually the grand final. So, a huge amount of pressure, a huge crowd there, lots of noise, potentially distracting this player from what is happening, as well as the different players around them. Adelaide is their team. They're probably pretty set to win this match. So there may not be that sort of cognitive load of it being a close match, but Erin Phillips, the player who's injured, happened to be the captain. And, she might be thinking about leading her team to a grand final, having to give a speech after the game when they accept the cup. And so there is this huge amount of cognitive or potential cognitive load happening here that is may be contributing to the elevated risk of someone in this scenario sustaining an ACL injury when they're having to react even in a one-on-one scenario like this. And so this is kind of the point where I think we need to get our testing to understand this phenomenon potentially of, how injuries are occurring in this scenario, whether there is a relationship between cognitive function to injury risk, how players are reacting in this scenario. And so it's not something that we can easily replicate in a lab environment. And updates in technology are potentially helping us get to this point where long-range LiDAR light systems, which is on the left here, are starting to be used in field sport. There is this singular sort of Z camera system that can do an okay job, I think, of getting biomechanics from larger groups in settings like this basketball court here. I don't quite think they're exactly at the same point as our 3D motion capture systems in the biomechanics lab, but I think to really start understanding how these injuries are occurring and the mechanisms behind them, we do really need to get out into the setting and scenarios where injuries are occurring and that cognitive load is at its highest. So that's where I'm going to finish today. I just wanted to wrap up by acknowledging some sources of funding that have allowed me to be here, in particular the Visiting Scholars Program from the University of Calgary and our Academic Study Program at Deakin. I want to thank Brent, Corinne, Colin, and Janae here at Calgary. They've been basically really helpful in getting me here, as well as my colleagues at Deakin University, and in particular Tess Rowley, because a lot of this work I presented today has formed part of her PhD. And she's obviously been really great at putting all of this together. So thank you for listening. Happy to answer any questions as well.
All right, floor is open for questions. Who would like to ask first one? Yeah, go ahead.
I'm just wondering, just with your observation of the sport, I know in the literature it's considered having to be linked to ACL care, but in this population, do you maybe observe like a vulnerability or susceptibility to either concussion or ACL care that are like converted? So like, say like maybe like broad strength, you see players more in the air, maybe that person at risk of concussion would be the
Yeah, there's probably not enough data there to establish those links. I think when you look at the studies that are establishing links between concussion and prospective ACL injury and some of those other factors you mentioned, they have really large data sets that allow them to do that. I think in the near future, that will start being explored in the AFLW because it's been going for 10 seasons now. They've collected this longitudinal injury database, but it's kind of just not there at the moment. And it is another potential explanation for the results we've seen that concussion and ACL injuries are obviously a problem in the AFLW, but they may be separate problems. We don't know yet. And that's kind of why we took a more mechanistic versus epidemiological approach in this work, because I just don't think we have the data to answer those questions.
Yeah, thanks for the question.
I was a little bit confused by that peak in the abduction moment at the knee. I don't study a lot of cutting maneuvers or anything, but you have this sort of valgus geometry in that cutting maneuver. And so the lower leg is abducted. And so I would think that the internal moment at the knee would be kind of like adduction. So I don't understand what the problem with that peak abduction is.
Those were external moments. I should have clarified. So, sorry, I think is it internal moments a Calgary thing? I need to follow your rules. Yeah, so that's an external
Moments in the northern hemisphere.
Yeah, sorry. Right. Yeah, so that's that external abduction moment peak that is kind of forcing that valgus collapse. And I guess to explain it further, like when we see that happen, it's when the player kind of hasn't oriented their leg and body in a nice direction to avoid that. And that's what we saw in our later studies with the video cue, that the players were already starting to orient their body. They could line up the moment. They weren't doing this on purpose, but the moment arm of the ground reaction force vector was much more aligned to the knee joint center because of that lean and orientation of the lower leg. And so, yeah, we felt that they were better prepared to kind of counteract that hazardous early loading peak.
And then I just have two quick ones. Well, that scenario was 30% of the ACL injuries. What was the other 60, 70% or?
Yeah, it was a bit of a mix. Like that sidestepping scenario was the predominant non-contact one. And so there were some contact-based injuries of people being tackled, some indirect contact scenarios of people going to the ball on the ground and being bumped. And so there was like less landing-based injuries, which we were surprised about, but the early years of the AFLW competition were less kind of vertical in nature, for lack of a better term. There were less high kicks and marking scenarios. It was more ground ball contests, people running around a little bit more rugby-like in a way. So we think that's why we saw more of those kind of scenarios. As the game has evolved, it's gotten a little bit more physical, and we've looked at some more injury data lately, and that scenario is still present, but we're starting to see more contested scenarios where ACL injuries are occurring, like mid-air bumps going for marks and coming down and landing. So I think, as this competition and the players continue to evolve, the injury prevention strategies are also going to need to evolve.
And then the last one was, and I'm sorry if I missed it, but you said that if you have a concussion, you're more likely to have, it increases your risk for ACL injury. And I was just wondering what the relative risk was, or odds ratio, or like how much more does it increase you?
Yeah, I can't quote exact numbers, so I'm not going to. But yeah, it's high. It's been established in a couple of particular papers. I don't know the exact relative risk numbers, but perhaps the interesting thing is it persists for quite a long time. Like it doesn't need to be acute concussion. I think some of the literature out there has looked well down the track, months to multiple months, and that elevated risk persists. And it kind of makes sense because the concussion literature also shows that there are some sort of long-term lingering deficits.
There's got to be a link between like how aggressive and how high performance an athlete is and their risk of getting concussion and their risk of getting an ACL injury. So how do you control for the, crazy aggressive players that are more at risk for both of these two injuries? How do you control for that potential?
Yeah, it's a fair point. I was actually reading some of the work out of Carolyn Emery's lab this morning, and I think they had a study on that, like more high-performing players in American football, more powerful players had a greater risk of concussion. So I think you're spot on with that. And even risk-taking behaviors have been sort of linked to injury. I don't think they control for it in those epidemiological studies. And we have some theories in this sidestepping scenario as well that the faster you do these cuts, the greater the load on your lower limb is going to be, and potentially increase your injury risk. I think it's fair for concussion. I'm not sure it holds as well for these lower limb injuries, because I think those players who are faster, more powerful, probably have a better ability to sort of do these tasks safer as well. They have higher loads, but they can, due to their physique or performance, right, they can position themselves better to do these tasks at greater speed without those elevated loads. But I like the question because it's a concept that we're interested in probing, like this performance versus injury risk trade-off, because the easiest way to reduce your risk of knee injury, like the players did in that study, is to run slower. But that's not very viable for performance. So it's an interesting topic.
Okay, we have an online question, then Florian, and then Bennett.
Go ahead, Robert.
Thank you. Hello, Aaron. I'm calling from Melbourne, Australia, and you asked, so I'll tell you I barrack for Carlton. The explosion in women's football in Australia has been absolutely spectacular in the last few years, and with it has come these ACL ligament injuries. And so I congratulate you for getting in and doing this research. It's really important. But when you look at women having 7 to 8 times the ACL injuries that men have, I'm wondering, have you run the same experiments with men who would probably have the same cognitive load as they come into those areas? Have you tried to use male participants as like a control against the questions you're asking?
Yeah, it's a good question. And thanks for mentioning you're a Carlton fan. I'm a Richmond fan, so I'm looking forward to round one this season. I'm sure you have fond memories of last year. No one in this room will get that joke, but I hope he does. Yeah, there's a real plethora of literature around sex differences in sidestepping biomechanics, and yeah, it's a valid avenue to understand this topic. I guess the reason we have avoided it in a women's football scenario is that we feel while they play the same sport, these players have had kind of vastly different exposure over time in their experience in the sport and the training that they do in an Australian football context. So that's why we kind of avoided doing this in the first place, because we felt they were a sort of non-comparative cohort. I think now, as the league is evolving, we can potentially pursue those avenues, but we haven't done that, and I guess I wanted to provide that context and reasoning as to why.
Right. Thank you.
Or
Yeah, so I was wondering, because you said that cognitive load, that for some point is also like dependent on pressure from the outside and from the environment. So I was wondering, did you guys, for instance, where you have some perfect object in both versus non-perfect object, or like, because that feels like it's pretty preventative.
Yeah, so like we haven't, to answer the question in a basic context. I honestly think the reason we haven't done that is sports psychology, and it is not a prominent topic area within our department at Deakin. We don't have a huge amount of sports psychologists, but it's a fair point. Like that cognitive load is going to be impacted by that athlete's psychology, and I think it speaks even more to, I guess, getting out into that scenario where they're actually performing, because that player coming into the lab who maybe has a different psychological makeup to another player, it might not be a problem for them. They're happy to get into the lab and do this sidestepping because it's a low pressure environment. You take them out into that match scenario, it will drastically change that cognitive load and pressure that they feel. Yeah, so it's definitely something that can factor into this scenario, I think. Again, I haven't investigated it. I myself am not a psychological expert in any fashion, so I probably shouldn't comment on it.
Could you suggest that there's a connection between ACL ruptures and concussion in women's football?
Sorry, can you just
In women's football, the connection between these two things.
Yeah, so
That means the ligament injury would be typically after the concussion, correct?
yeah, in those studies that have been able to establish that,
Have numbers.
that's what they have. Perhaps similar to the first question that was asked, in women's Australian football, there simply isn't the data yet and amount of injuries, I think, to really establish that. And so I think in the near future, we can potentially sort of look into that and understand if, the ACL injuries are occurring before or after the concussion, because it would make more sense if there was a link that had happened after. But the competition having run for 10 seasons now, there really isn't the sort of amount of data to truly answer that question yet. So I think it will be something for the future.
And you assume that it's only the case in women's football, not in men's, correct?
Yeah, we haven't.
What is different?
I think the literature in this area has, I'm trying to think back to the studies, but I would say that they are both male and female data in those studies that have established a link. The reason we focused on the women's competition here was simply because of the really high rates of ACL injuries and concussions that were occurring. Concussion and ACL injury is a problem in the men's competition as well. It's perhaps the inverse though, where the worse or more problematic injury in women's sport is the ACL injury, and then in the men's it's probably the concussion or the ACL injury. But both injuries happen in both competitions, and so I think it would be fair to explore it in a men's football context as well.
But why do you think that there would be a change?
I don't think there would, to be honest. We could have equally run this study in the men's competition. But yeah, like I said,
Same results.
It could be the same results. I think we'd have to do the study to understand it. I would hypothesize the same thing. And yeah, I would probably have to look at the men's competition injury data to understand whether, I guess, the ACL injuries are happening in the same way. And another reason we went down the women's competition avenue was because we saw those reactive change of direction injuries happening so commonly. I wouldn't be confident that that would be the major injury mechanism in the men's competition. So we might see different results, or it might not be as big of a problem. And yeah, so we started our focus on the women's for those reasons.
I have a question before I get to you, Walter. Is the injury risk in females in just not Australian, well, just football in general, also as high, or is it specifically Australian football is 7 to 8 times?
Yeah, so you typically will see an elevated risk in females across most sports. In Australia, like the other sports we play that are sort of ACL injury prone are probably soccer. Netball is a sort of predominantly female sport, so you can't really look at that. And the literature I've seen is it's pretty consistent of that sort of 1.5 to 2 times higher in other sports in Australia and in other locations. When you look at that sort of 6 to 8 times higher rate that we saw in the early seasons of the AFLW, I'm not sure I've seen that as high in any other sport in Australia or globally, like soccer, lacrosse, volleyball, basketball as well. I don't think any other sports have really reached that high.
Yeah, I'm asking because I've been doing a little bit of literature review of my own for my study, and I think football in general, not Australian football, but football came up and women were at a higher risk, but I don't think the number was that high. So I'm wondering, and I don't think you have the answer to it right now, but what is specifically different in the Australian rules that is maybe putting them at a higher risk? I'd be curious to look into that a bit.
Yeah, so in the early years of the competition, we actually wrote this sort of opinion piece on this topic because a lot of the conversation when this happened was around biological differences in females, which is sort of the typical explanation for that higher injury rate, different sort of neuromuscular factors, anatomical factors, and we think that is sort of potentially relevant, but one of the things that is unique about Australian rules football is that exposure and background in it for females, particularly when this competition was introduced. You had players who had maybe sort of semi-regularly played the sport. They had a lot of players come across from different sporting codes who didn't have that Australian rules football background. And even when, you look at female sports in anything, whether it's Australian football or other sports, there is typically less sort of training exposure and less exposure to sort of, I guess, advanced S&C practices, medical support stuff. And so we kind of hypothesized this overall biopsychosocial framework for why this might be happening. It may not just be because they're females. It's because as females, as they've grown up, they haven't been able to play this sport. They haven't got the same exposure as male athletes in their sport. And so we think, yeah, there's a decent range of explanations, and you need to address all of those factors to reduce the injury rate.
Walter?
Thanks very much, Tom. So I don't know anything about directional change or football, but I was wondering, one comment that struck me a little bit, and I'm not sure if I would agree with it, is that you said when people do the movement faster, there's greater forces, there's a greater risk for injury. And I wonder if that's correct, because I would assume, independent of how big your load on the knee is, if your knee is properly aligned, you're not going to tear the ACL. So then when I think about the sport, in the laboratory, you do a sidestepping movement where people know they do it, they probably don't get injured much. And then in the game, they all of a sudden with change in direction that they anticipated, they know where the other player is going. So they make a quick change in direction that they kind of know. So my hunch would be that the injuries occur when you think the opposite player does something and you're prepared, your muscular system and your neuromuscular framework is prepared to go left. But now all of a sudden you realize you actually have to go to the right. And I wonder if it's that unanticipated one where your motor program is not ready. So the forces will actually be relatively low because your muscles are not ready. But your muscles are not ready. And so the movement is somehow awkward, strange. I wonder.
Yeah, no, it's a great point. So I guess the idea that faster movements produce high loads comes from, I guess there's been some work that's done sidestepping with faster versus slower approach speed, and using that proxy of the frontal plane knee moment that goes up when you run faster, and therefore there is an elevated potential for injury risk, which is a valid point in a way, but doesn't reflect that realistic scenario that you're talking about. And I think the scenario you're talking about is something that has kind of bothered myself and colleagues for many years in this topic area, that these ACL injuries happen in scenarios that players do hundreds of times. Like that sidestep that player performed wasn't that unique. They would have done that safely so many times on a football field, yet this one particular time they ruptured their ACL. And so we've sort of been trying to figure out for a long time how to probe this idea of this anomalous scenario coming up and what is causing that. And it's a tough question to ask. And I think, again, the only way that we can really sort of understand is to try and get some of that data when that scenario that you described is occurring, and data around that scenario to see whether it is what the opposition player is doing that's causing them to do something different and perform movement in a different way, or whether we can get some of that sort of neuromuscular biomechanical data in that scenario where something is happening that causes the injury to occur. But yeah, totally agree with the premise, and I think the probing or understanding of the problem is what we need to solve.
The other thing that I thought was interesting, the male versus female, that in males, it's a sidestepping. It doesn't seem to happen so often. Like an ACL injury. And then you also, I don't know how long football has been played like this in Australia for the males, but I assume for a very, very long time. Then you say for the women, it's a relatively new thing. Could it be that the male players are just the better players in anticipating, because they have done this for the past 50 years. You know, like you know, Canada doesn't play regular soccer as well as Brazil, because they're still learning how to play soccer.
Yeah, again, I agree with it. I don't know much about Canada and soccer, but
You think there could be, you know, a learning element when you have played this for dozens of years and generations. Your mother played, your grandmother, and you know, you kind of know just better how it works.
yeah, it's it's a fair point, and I can sort of relate it to conversations that happened around the early times of the AFLW. You know, there was a lot of commentary on the quality of the competition, a lot of commentary on the sort of injuries that were happening. It was low scoring versus the men's competition, and everyone was comparing that directly. You know, the 2017 AFLW season to the 2017 AFL men's season. But in reality, we should be comparing the 2017 AFLW season to like the 1910 or whenever the men's competition started. I guess
This doesn't work.
well, the problem is we don't.
It's much slower.
Yeah, we don't have data from back then on ACL injuries either. But like, yeah, there's definitely this development and exposure element to the sport that I think is related to the injuries and how they're occurring. And I guess I don't want to wait for in 100 years' time for the women's competition to not have as many injuries. And so, yeah, I guess we're trying to pick up on those areas to address now to hopefully accelerate it to the standard that I guess we see in the men's competition at this point in time.
And I just rewatched the 1970 soccer World Cup final with Pelé last time with Brazil. You know, I meant that Brazil is a Pelé won. And you cannot compare that, because the game is slower than women play today. So, you know, compared to how people play today, it's just a completely different game.
Yeah, and it potentially sort of speaks to the question about you know, can we probe this in men's players as well? Like, again, I'm not sure whether it is that comparative sample. Like, we look at the injury rates to explain or look at that relative risk, and it may not be the most viable thing to do in the sense that the games are different, but it's what we have. And yeah, so I think that sort of competition or sex specific approach is probably relevant. Yeah.
The other thing, just that I found the relationship, you know, concussion, ACL injury, that is intriguing. And I was wondering, you know, if you didn't only do cognitive tests or reaction tests, but the muscular tests, and particularly thinking about, let's say, the rate of force development, would that potentially be affected and slower post-concussion? There be certain, you know, synergies, muscle synergy patterns that just come in slower after concussion compared to before.
Yeah, I would have loved to have the data for you on that. We floated the idea of doing some, this is not my area of expertise, I'll try and explain it, like the transcranial magnetic stimulation to sort of probe that link between the brain and the muscle in this project, but it wasn't feasible within the scope of it. But I agree, we certainly, to understand that potential mechanistic link, I think that sort of research would need to be done to, you know, go, is, you know, we were just doing computerized tests, like can they react with their fingers just as quickly? But when that turns into a motor function task, yeah, the connection between the brain to the muscle, like, is that what is potentially driving the elevated risk? It could be. I'm not that aware of much research in that space, but I'm sure sort of people are probably starting to get to it.
Just out of curiosity, what's the most common way of getting a concussion in female Australian football?
Running into someone else really fast.
Is it like a head to head?
Yeah, head. Yeah, so I could probably describe that a bit better. There's probably two common ones. The first one is what I tried to explain there, like running into a collision head on. And then the other one that tends to happen is, and they're trying to eliminate this from the sport, the sling tackle and the head hitting the ground after that. So you throw someone into the ground and their head bounces back, which can also happen in sort of marking contests and get pushed off balance, hit the ground and hit your head. Those are probably the two common ones I can think of. And it potentially goes back to Brent's risk-taking question earlier that there are players out there who maybe just like really going hard at it and they get concussions because of that.
A question from Ben and then Tori.
Is there a link between injury risk and the surface that they play on, whether it's grass or turf, and maybe the shoes or the equipment that they wear? And is that predispose women that play Australian football more than, say, women that play rugby or basketball? And would that potentially explain any differences between what you see in this specific context versus the men or other contexts?
Yeah, I'm not sure I would explain the sort of anything from our data because we did this in a controlled lab environment, but there were some sort of hypotheses around the AFLW and surface because the time of year that it is played is different to the men's competition. Australian rules football is a winter sport, and for whatever reason, they don't want to play these at the same time, so they play the women's in the summer. And there were some theories around, the ground hardness and traction, whether that could have affected injuries. Not sure of any sort of empirical research that was done in that space, was more hypothetical. And then on the footwear side of things, I think that's a fair question as well. There's some research happening now, I think, from La Trobe in Australia that is looking at potential like female specific Australian football boots because the competition came on so quickly that they probably just altered the men's boots to be slightly smaller or something for women to play in and marketed them as the women's footwear. So I think they're valid points. They haven't been proven yet, but people are sort of researching those spaces.
All right, thanks for the talk. I just had a question about if you're planning to implement any like estrogen or estrogen testing, because I understand that there's a connection between like estrogen and concussion, and also there's like potential links to laxity and stuff.
Yeah, it's certainly been a limitation that we've acknowledged in this research that we didn't sort of control for the menstrual cycle phase and its potential impact on we didn't necessarily look at that in causing concussions. We were just getting the concussed players in, but I think there has been some research looking at menstrual cycle phase and like movement biomechanics and how it can affect it. Really hard to control for in this cohort. Like it was a small cohort of those sort of elite Australian football players that we had limited access to because there's a few teams in the state that we could do testing from. And so it was a decision we made that, we wanted to take the participants that we could get. And then, you start looking into participants who are on oral contraceptives versus not, and that can throw a whole lot into how you do this. So, yeah, I can't really answer that outside of saying it was a limitation of the work.
Yeah, do you plan to like implement any testing? I mean, also more so like looking at the link, because there might be, or it could be potentially some mechanistic elements there with laxity, like decreasing estrogen after concussion.
Yeah, it's not my area of expertise. I know we have a couple of researchers at Deakin who are really focused on menstrual cycle and athlete health and well-being and injuries. They've been focusing on that more in a running or endurance sport context at the moment because like links to revs and that's kind of the focus area they've been on. But I certainly, it could be a collaborative opportunity in the future between our biomechanical group, but another group that's looking at concussions and how we can link up with those researchers in that space. Yeah.
All right, I think with that, let's thank Dr. Fox for his talk.